Wednesday lab prep, might go over some more homework. Thursday lab, Friday quiz. I probably won't make the lab due until probably Monday. Isn't that way? Because you have the quiz or lab on Friday or Thursday. I'm not going to make you turn it in on Friday when you're supposed to be studying for a quiz. Fair enough.
When's the last day of the quarter?
20th. So not next Friday, Friday after.
Oh, okay.
So you still got a little time yet. Okay. All right, so let's look at last thing we're going to do. Okay, so now we're going to talk about balancing redox reactions again. Balancing redox reactions in basic solution. Okay. Now, we were doing them in acidic solution before, right? And what were the two things we said were present that might not be there initially in the formula? Because it's taking place in acidic.
Water and H plus.
Water and H plus. Okay. Now a basic solution, what's going to be present? OH minus and
H.
no,
H plus.
no,
Water.
water. Okay. Are we clear with that? So this time the things that are present are water and OH. Okay. The thing is, though, is we're going to act like it's acidic at first. So all the stuff that we do for acidic, we're still going to do, but we're going to add an extra step. Okay, so we're going to balance all atoms other than H and O. We're going to balance O using H plus. We're going to balance O's using, balance all elements other than H and O. We're going to balance O using H2O. We're going to balance H using H plus. And then we're going to add in a second step, because think about it. If I balance H's using H plus, there's not H plus in the basic solution. I'm still going to do it, but then I'm going to fix it by bringing in OH's. So let's look at that. So, one, I'm going to balance as if the solution is acidic. So all the steps that you've learned up until now, you're still going to apply those. But we're going to add an extra step. After adding H plus, and again, we're going to add H plus. That's an acidic thing, right? We're still going to do it, but we got to fix that problem because it's not an acidic solution. After adding H plus, we're going to add the same number of OH minus as H plus to both sides of the equation. In order to form water. After adding the H plus, we're going to add the same number of OH minus as H plus to both sides of the equation. So let's say on one side of the equation, I add 3H plus to balance up. Well, it's probably going to be an even number because we're adding H2Os. But let's say we add 4H plus to even up the H's. Then I'm going to add 4 OHs to both sides of the equation. On the side that has H plus, if I have 4 H pluses and 4 OHs, that makes 4 water. And you're allowed to have water. Does that make sense? On the other side of the equation, you'll just have 4 OHs, which we're allowed to have for basic. Okay, and then the only other thing, this isn't really an additional step, but there's usually more to cancel here. So we're going to say, be sure to eliminate all spectators. From the equation. Okay, notice I'm not saying spectator ions, because sometimes the spectators are just gonna be things like water, which aren't ions. Let's do an example. Okay, so this is I negative plus MnO4 minus yields I2 plus MnO2. And just to be clear, I gotta tell you it's basic. I gotta tell you it's acidic. There's no way for you to know that unless I tell you. So on the test, it'll say, balance this redox reaction that occurs in acidic solution. Balance this redox reaction that takes place in basic solution.
Are there reactions that could take place in either or?
My guess would be they can, but they'd have to be the reverse reaction. So like, if one reaction goes this direction and that's taking place in basic, maybe if you flip that reaction around, it could take place in acidic. That would be my guess. So maybe not in the same direction. Today might require a little extra Mountain Dew. Right, Tyler? How long was our bus ride? Took forever. Weather was bad. What's that? -1. Their kid took their straps down on the bench before he went behind his bench. That's why I'm always freaking out. Get behind the bench before you take your straps down. Because if it's a close match, you know, you're wrestling somebody like Reynolds, you walk off the match and you take your straps down, boom, team point. So they got 1 point taken away from their no points. So they got 78 to -0, or -1. That's insulting, you know, because it was bad, wasn't it? It was bad.
Did not win the match.
Not the whole night. And their best kid, which he isn't bad, wrestled Dorian and Dorian Crosby, and that's a middle school team. And he was giving up like 30 pounds to Dorian, so Dorian was kind of pretty good. Okay, monoatomic ions have an oxidation state equal to charge. By rule, in substances, oxygen is -2. And if each oxygen is -2, and I have 4 of them, that's -8. Yep.
Oh, I was gonna say.
What is it?
+7.
It's got to be +7, right? Because if this is +7 and that's total of -8, that adds up to -1. Atoms of an element? 0. We got a rule for O, -2. If you got 2 -2s, that makes this +4. Okay. Okay, so everything's got to add up to -1.
Okay.
Does that make sense? Yep. So that's -8 and +7. There you go. Okay, so what's going on here? Let's see. Well, I is going from -1 to 0. So the oxidation state went up, -1 to 0. So you must have lost an electron. So this is what? Nope. Oxidation. So that's oxidation. And so manganese here goes from +7 to -4. So this oxidation went down, it's reduced, or reduction. Right? Yep.
We never use oxygen.
If it changed. Yeah, think about it like this. Let's say on one side of an equation you have MnO4 minus, that would be -2. Let's say on the other side of the equation you have O2. That would be 0. Gotta change.
Are you only gonna ever have one oxidation and one?
No, sometimes, well, put it this way. Yeah, but sometimes you might get something like this, where let's say, for example, let's say that's O2 here, and let's say you got MnO2 plus MnO4 minus. So this is 0, and this is -2, and this is -2. So sometimes this one thing might connect to both of these things. So whatever it connects to.
So you have to look in order on the steps to find out, like the higher up on the list.
What? What? No, we're not doing that anymore.
What? What do you mean?
You talking about the activity series?
No,
Higher
this
up
one's
what?
us. I don't know how to say it. Like what's higher up on the steps? I'm looking because that's what's it called, a monatomic ion, right? That's why it's 0. That's
No,
why
there's no monatomic ion. That's an atom of an element.
atom of an element. That's
Okay.
why it's 0.
Yes.
And then on the other side, since it's with something else, that's why it's -2.
Yes.
So if it comes first on that list, that's what takes place.
What list are you talking about?
The list of steps that you gave. It was the list that you gave us from the notes the other day.
No, not if it comes first. It's just if it's an atom of an element, it's 0. That list is just saying,
Oh, okay.
okay, it's not an ordered list. It's just saying that O in its compounds is -2, F is -1, H is +1, monatomic ions are equal to charge, atoms of an element are 0.
Okay.
So it's just, it's there's not like an option. It's just gonna be one of those things. I see what you're saying now on the list then.
That oxygen, like negative, if that oxygen is, will that atom, just a single oxygen, never have a charge?
We're not talking charge, we're talking oxidation state. Okay? It has an oxidation state of 0, so it has an oxidation state, it's just 0.
And it has like negative.
It can, but we're not gonna deal with peroxides. That's what I was saying, that's a possibility. So the point is that those two oxygens are sharing electrons. They're like in a tug of war over the electrons. Nobody's winning the tug of war. They're exactly the same atom. So it's completely equal sharing, so nobody gets a surplus of electrons. That's why it's 0. It's like they haven't pulled any electrons, they haven't lost any electrons. Good? Okay. All right, so let's move on to this. All right, so this is, I like to do my oxidation first. So I'm going to do I negative yielding I2. So my other reduction is MnO4 minus yielding MnO2. Okay, so I'm going to approach this like it's acidic. So the first thing I'm going to do is balance elements other than hydrogen and oxygen. And I look at this one, and there's a problem, right? What do I got to do? Go ahead, Jake.
Put a 2 in front of I negative.
2 in front of I negative. So I'm going to put a 2 here. And now I've got 2 I's and 2 I's. Over here, I'm good to go, aren't I? There's 1 Mn in each case, so they're balanced. What do we balance next? H or O? No. I'm sorry. What do we balance?
Oh.
O, right? Because when you balance O, what else are you bringing in?
H's.
H's, okay, so nada over here.
4 to 2,
Okay, so what do we do to balance it?
bring in 2 H2Os.
2 H2Os on this side, right? So I'm gonna have M and, sorry about that, man. You're like, I thought I got it. M and O2 plus 2H2O. Balance H's using H plus, good. So I'm going to bring in nothing here. Over here, 4H plus. Okay, now there's where we just created a problem. This is not an acidic solution. H pluses are in acids. So we can't have that. I don't have to worry about anything here because there's no H pluses to worry about. Now when I add my H pluses, or my OHs here, this step, after adding H plus equals the same number of OHs each side of the equation, the way that I like to do it, and you can do it whichever way you want, is on this side, I usually put 4OH right under it to remind me that that's going to turn into water. You see that? 4H pluses and 4OH minuses make 4 water. But over here, it's not going to combine with anything, so I just string it on to the end. Which is there.
So is that 4OH on the left side in?
It's in there, yeah.
You're,
I'm just writing it there to remind myself in my next step I'm going to combine the two. Because you're allowed to have